Right, tonight's video is going to cover complex numbers, which will include some basic concepts and some operations on complex numbers. So first of all, some basic stuff. We know that there are no real numbers that will solve this equation, because I can't take the square root of a negative number and come up with a real solution. Therefore, the number I will have the following property. I squared is equal to -1. So following that, I would be equal to the square root of -1, and that is called an imaginary unit, the unit I. And the numbers of this form, a plus bi, are called complex numbers, where a is the real part and b is the imaginary part. And this is their standard form. And this shows us that a number that looks like this, 7i, is pure imaginary. 7 plus 2i is non-real complex, and a plus bi is standard form. Now we'll go through a couple examples. To simplify the square root of -16, I will first take care of the negative part by taking out an I. And after having done that, I'll take care of the square root part if I can, simplify it, and I can simplify the square root of 16 into the square root of 4. So my final answer becomes the 4i. So here's a similar problem. I need to simplify the square root of a -70, so I'm first going to take care of the negative by taking the I out. And then my next task would be try to simplify 70. So I can't take the square root of 70, so then I would try to factor. 70 is 10 times 7, 10 is 2 times 5, and since I don't have any pairs of numbers, then the simplest form that I can present this radical in is I root 70, which will be my final answer. And again, another one of these. First thing I need to do is take care of the negative part by taking out an I. And then I'm going to simplify that 48. I know that 48 is 6 times 8. And 6 is 2 times 3. 8 is 2 times 4. And 2 times 2 is 4. So then, finding my pairs of numbers, I have 2 pairs of 2's that will come out. So I took those 2 pairs of 2's out, and 2 times 2 gives me 4. And I have the root of 3 left over inside. So my simplified final answer is 4i root 3. Alright, so that was the basics. Now we're going to take care of some operations with complex numbers. And products and quotients with negative radicands are simplified by first rewriting negative root of a as I root a for a positive number. And then the properties of real numbers are applied together with the fact that I squared is equal to -1. So it's very important that before we do anything else, we take any negative roots and take the I out to make them positive roots. So again here, a word of caution: when working with negative radicands, use this first, take the I out first before doing anything else. So in this case, we're going to take care of those negatives first, which are underneath the radicals with the 7's. So take an I out of each one, and that will be I root 7 times I root 7. And remember, when we're multiplying radicals, it's the outside number times the outside number, and the inside number times the inside number. So this is going to become I squared root 49. And then simplifying that, because I know I squared is -1, and I know the root of 49 is 7, so my final answer will be -7. Alright, so this will be a similar type problem. Take care of the i's first. Take out an I, and then you make that root 6. And take out an I and make that root 10. And then we do outside times outside, so that makes that I squared, and then root 60. I can't take the root of 60, so then I would try to factor it. And that factors into, let me make this an I squared, factors into 4 and 15, which 4 is 2 times 2, and this is 3 times 5. So I have a pair of 2's that are going to come outside. Okay, so I've got, oops, let me redo that. So this is going to equal I squared, and then I got my 2 on the outside, and the root of 3 and 5 inside makes 15. But remember, I squared is equal to negative 1, so this is going to be negative 2 root 15. Alright, here we have some we're going to divide. Remember, we're still going to take care of those negatives first by taking out i's. So this is going to be I root 20 divided by I root 2. And so I divided by I here will be 1, so we can get rid of that, equals the square root of 20 over 2. That's a rule of that we can use to simplify radicals. And 20 divided by 2 is 10, so we're left with the square root of 10, which is not able to be simplified, and that's our final answer. So for this problem, we have to write this expression in the standard form for a complex number. And so the first thing we need to take care of, remember, is this negative under the radical. And while I'm doing that, I'm also going to simplify this as much as I can. Alright, so the first thing I did was just take out the I to take care of the negative part. Now I'm going to factor 128. Now rather than factor it all the way out, I know that I know that 64 is a perfect square, so I can take the square root of that. So this will become 8I root 2. So I've just rewritten that over here to the right hand side. And now I'm going to take my 4 and divide it into each part here, but not the radical part. So we're only going to divide it into these two portions. So negative 8 divided by 4 becomes negative 2. And positive 8i divided by 4 becomes positive 2i, and then our root 2. And that is the simplified form of this expression in standard form. Alright, now we're going to move into some operations. And anytime we're adding or subtracting complex numbers, we want to add the real number parts or subtract them, and then add the imaginary parts together. So it's kind of like combining like terms. So we want to put the real numbers together and the imaginary parts together. So this one, I would do 3 plus negative 2, which gives me 1. And then negative 4i plus 6i, which gives me positive 2i. And it's written in standard form, and so that is my solution. So we can do the same thing in this situation. Real number parts, that gives me negative 6. Imaginary parts, that gives me negative 8i. It's in standard form, so there's my solution. Subtraction works in the same fashion, except I need to make sure that I am distributing this negative. So when I do that, I get negative 4 plus 3i minus 6 plus 7i. Put together my real number parts. Negative 4 and negative 6 is negative 10. And 3 and 7i make 10i. And it's in standard form, so I am completed with that problem. Here we're moving on to the product, multiplication. So we're going to multiply these just as we would any normal binomials. They just happen to have imaginary parts. So utilizing the FOIL method, first, outer, inner, last, I'm going to distribute this 2 this way. And 2 times 3 is 6. 2 times 4i is positive 8i. And then likewise with the negative 3, Negative 3 times 3 is negative 9i. Negative 3i times 4i is negative 12i squared. Now I combine like terms and simplify where I can. So positive 8i and negative 9i give me negative I. And then this I squared, remember, is equal to negative 1. So negative 12 times negative 1 would be positive 12. Then I can combine the 6 and the 12, and that gives me 18 minus I for my final answer. The powers of I can be simplified as following. I to the first power is I squared is negative 1, I cubed is negative I, and I to the fourth is 1. And then it starts over. I, negative 1, negative I, and so on and so forth until infinitely it goes on. I want to mention the property of complex conjugates. If I have this first binomial as a plus bi, and the second one differs only in the symbol, in the from addition to subtraction, then rather than having to FOIL it out every time, I can simplify it by taking the a and squaring it, and taking the b and squaring it. So there should be no imaginary parts left. So to divide complex numbers, we're actually going to be multiplying by the conjugate. Now remember, the conjugates, just like when we were doing the conjugates of radicals, the conjugate only changes the subtraction to addition or addition to subtraction, whichever it may be. So we're going to multiply the top by 5 plus I, and the denominator also by 5 plus I. Alright, so simplifying just the numerators, 3 times 5 is 15. 3 times I is 3i. Then taking the 2, 2i times 5 is 10i. And 2i times I is 2i squared. And just as in the previous example, I'm going to collect like terms. So this makes 15 plus 13i. And I know that I squared is negative 1, and negative 1 times 2 is negative 2. Putting together the 15 and the negative 2, I get 13 plus 13i. For my numerator, my denominator. So now applying the rule that we just spoke of, instead of having to FOIL this out, which I could every time, I'm just going to take the a part, which is 5, and square it. So that gives me 25, plus take the b part, which happens in this case to be 1. 1 squared is 1. And now I simplify that bottom. And so this becomes 13 plus 13i divided by 26. And now I'm going to take that 26 and divide it into each part of that. And 13 divided by 26 will give me 1/2 plus 1/2 I. And it is in standard form. Alright, this will be our last example. And it says, write the quotient in standard form. So to get rid of the sign on the bottom, I'm going to multiply by its conjugate. Now since there's no number in front of here, I could, write this as 0 plus I. Then I'm just going to change, remember the symbol, so multiply by negative I over negative I, which gives me negative 3i divided by negative I squared. And now I'm going to simplify. This negative I squared is equal to negative times negative 1, because I squared is a negative 1, over negative 3i. So that gives me negative 3i over positive 1, which is negative 3i. And I'll see you in class tomorrow.